Open your book to page 378. This lesson is on finding the slope. The slope is the steepness of a hill. So example that would be going up like that. And so let's say if you have a hill like this, so what would be the slope of that? The definition of the slope is, if you look in the book, the slope is equal to the rise over run. So rise is up and down, and run is sideways. So basically what you want to do is you want to draw a triangle, and so these would be the rise. Okay, so just pick any 2 points and you draw a triangle. Rise is how much you go up or down, and the run is how much you go sideways. So rise over run, that's your slope. So slope is a ratio of the rise over run. Okay. Now when you put in a formula, the slope using the letter m for slope, and this is equal to y2 minus y1 over x2 minus x1. Now what these things are is that this is your first point. So you start out at your point 1, you end up at point 2. So this is going to be your x1, y1. So this is the point number 1. So this is the x coordinate of point 1. And again, the subscript 1 means this is the point number 1. So this is the x coordinate of point 1, y coordinate of point 1. Over here you're going to get x2, y2. So this is the x coordinate of point 2, y coordinate of point 2. Now the rise is going to be equal to y2 minus y1. Right? So it's y2 here, and that's your y2, here's your y1, right? You're looking at y, right? So the difference between that is you use the end minus the beginning. Okay? Same thing over here. So that's your x2, that's your x1. So the run is equal to x2 minus x1. So that's where these things came from. The run is x2 minus x1. Again, but if you're not sure where this came from, well, think about your number line, right? Let's say you have 2, 3, 4, 5, 6, right? And if, okay, 1, okay? Now, let's say if you want to find the distance between 2 and 5. So what's the distance between 2 and 5? How are you going to find that? Well, it's 3, right? Well, how do you get 3? Use the end minus beginning. So you use 5 minus 2, that's how you get 3, right? So again, to find the distance of something, you're just going to use the end minus the beginning. So use the end minus the beginning, and that's how you get the distance. Right? So that's how you find the slope. So here's your formula. So now let's go to example 1. So you have 2 points. You got -3, 5, and you got 6, -1. So here's your point 1, point 2. So that's your x1, y1. So again, this is the x for point number 1. Y, this is the y for point number 1. That's your x2, y2. This is the x coordinate for second point. This is the y coordinate for second point. So again, subscript 1 means point number 1. Subscript 2 means point number 2. So write down your formula. So m equal to y2 minus y1 over x2 minus x1. Okay, so you just substitute the numbers. So y2 is -1, y1 is 5, x2 is 6, x1 is -3. So it's very important that you put in parentheses when you substitute so you can keep track of your negatives. So when you do this, you're going to get -6 over 9, and you reduce by 3, divide by 3, divide by 3. So your slope is going to be equal to -2 over 3. Okay, so let's just continue. So let's go to example 2. You're looking for the slope through the point A and point B. So point A is your -2, -4. B is 5, 1. So that's your first point, second point. And from here, so that's your x1, y1, x2, y2. So slope equal to y2 minus y1. Again, write down your formula. And you substitute. So you got 1 minus negative 4, right? 1 minus negative 4, the end minus the beginning over 5 minus negative 2. So slope equal to, so it would be 5 over 7, and that's your formula. Okay, now if you want to visualize how is this, you can look at from the graph also. Okay. So let's say if you graph this, so the first point is negative 2, negative 4. So you got negative 2, negative 4, right over here. And next, so your point 1, and point 2, so this is your negative 2, negative 4. Second point is 5, 1. So you don't have to do this, but I'm just showing you to help you to visualize how this graph related to this. Okay. So this is your second point, and that is your 5, 1. Right? So if you were to draw your triangle, and if you count the squares, okay, if you notice there are 5 squares over here, right? Look, 1, 2, 3, 4, 5, right? And the reason for it is because 1 minus negative 4 will give you 5, right? 1 minus negative 4 give you 5. And over here, for the x, right? 5 minus negative 2 give you 7, right? So 5 minus negative 2 gives you 7. Or you can count it, right? So starting from here, right? You go 1, 2, 3, 4, 5, 6, 7, right? So again, that's how this related to that. So once you understand where this came from, you don't have to draw the graph. You can just go and substitute and you work it out, right? So again, the top, this is a rise. So when you do this, you subtracting, you figure out the height of this hill, right? And then when you subtract x2 minus x1, you find out the horizontal distance of that. So it'd be 5 over 7, and that's your slope. Okay, let's go to example 3. So you have point E at negative 4, negative 3, and you have point F at 2, negative 3. So again, slope equal to, so this is your point 1, point 2, x1, y1, x2, y2, right? So you got y2 minus y1 over x2 minus x1. So slope equal to negative 3, right? y2 minus y1, and you got 2 minus negative 4. So m equal to 0 over 6. So m equal to 0. When the slope equal to 0, what you have is that there's no steepness. That means the graph is horizontal. So if you were to graph this, so don't write down no slope, okay? Do not write down no slope. Just 0, it just means 0. So what you have is, you have negative 4, negative 3, and this one, so this is your point 1, and point 2 is 2, negative 3. So that's your point number 2, and you connect. So slope equal to 0 means there's no up or down. It just stays flat. So when slope equal to 0 means you have flat surface. You don't have any up or down. Okay? So that's what it looks like if you were to graph. Okay, now let's go to example 4. Example 4, you have 2 points. You got R at 4, 5, and your point S at 4, negative 2. So when you're using the formula, okay, again, just go through the same thing. So this is point 1, point 2, so x1, y1, x2, y2, right? So slope equal to y2 minus y1 over x2 minus x1. So slope equal to negative 2 minus right? Negative 2 minus 5, and you have 4 minus 4. So m equal to negative 7 over 0. So that means the slope is undefined. Now, when the slope is undefined, what you have is you have a vertical line. Okay, so when the slope is undefined, you have a vertical line like this. So if you don't believe that, you can check these things out and by plotting the points. So you got 4, 5, right? So you got 1, 2, 3, 4, and you got 5. You got 1, 2, 3, 4, 5. So 4, 5. So that's a point over here. Next one is 4, negative 2. So you got 4, negative 2, right over here. So when you connect the two, you end up with a vertical line, right? So when the slope is undefined, that means the steepness is infinite. Okay, basically what you have is you don't have a hill, you have a cliff. Okay, so that's what this is. So think about as you have a cliff. Therefore, there's no steepness. It's infinite. Okay, so just write slope is undefined in this case. Now, when you go to page 381, the meaning of the sign of the slope. When slope is equal to positive, that means you're going uphill. Okay, slope is positive means you're going uphill. Again, you always go from left to right. And so when positive it means you're going uphill. When slope equal to negative, that means you're going downhill. So as you go from left to right, negative means going down. Okay? So again, if the slope is positive, means you're going uphill. When the slope is negative, means you're going downhill. Now, next one is a slope-intercept form. So on page 381, you have the slope intercept form of the equation. So slope-intercept form basically means you have a y equal to mx plus b. So that's your slope-intercept form. The reason it's called a slope-intercept form because this is your slope. And this is your intercept. And remember what intercept means, right? Intercept is where it crosses over the axis, right? So this is your y-intercept. So this is where it's going to cross the y. So how you're going to use this information? Well, you can use it to graph something, okay? So let's go over example 5. So on page 382, example 5, so you have y equal to 2x plus 3. So it says identify the slope and the y-intercept. So in this case, the slope equal to 2, and y-intercept means b, so b equal to 3. So that's all you have to do. Okay? So that's for example 5a. Now 5b, you got y equal to negative 1/2 x plus 5. So the slope equal to negative 1/2, right? That's what this is, right? Slope, intercept, right? And the b equal to 5. Okay. And 5c, you got y equal to x minus 6. I'm going to write side by side so they can line up. So in this case, m equal to 1, right? When you don't see a number, it's 1. And b equal to negative 6. Okay. So again, this is your y-intercept. Y-intercept using the symbol, small b. So again, slope, intercept, slope, intercept. So 5d, you got y equal to 4x. So in this case, the slope equal to 4. Now there's no number over here. That means b equal to 0. Okay, because base means plus 0. Okay. Now let's go to e. We got y equal to 4. So in this case, the slope equal to 0 because there's no variable, and intercept is equal to 4. Okay, and that's it. So slope is a number before the x. Okay, so now what we're going to do next is we're going to use the slope intercept to graph. Okay, So let's go to example 6. Example 6, you got y equal to negative 1/2 x plus 5. So when you have a slope and intercept, to graph this is very easy. So again, over here you got slope equal to negative 1/2 and intercept equal to 5. So this is your y-intercept. Y-intercept means where the line crosses the y-axis. So when b equal to 5, so you go 1, 2, 3, 4, 5. So that's a dot right over here. Now the reason this intercept 5 you put over here is because this is when x equal to 0. See, when x equal to 0, this is gone. So you have y equal to 5. So this came from that. But instead of doing that, you just look. Intercept is 5, right? That means you're going to cross the y at 5. That's what this means. Again, y-intercept, intercept means where it's going to cross. So y-intercept means you're crossing the y at this number, so 5. Now next information you're going to use is the slope. Okay? See, what happens is the slope equal to negative 1 over 2. Remember that you can make the negative either on the top or on the bottom. It doesn't matter. Okay? So let's say if you put negative on the top, that means you go down, right? Because the top number is for up or down. The bottom number is for side to side. So if it's positive, it go up. Negative, it go down. So what it's saying is that the slope is negative 1 over 2 means you go down 1, you go over 2. Okay. So this one you don't even need to look for the coordinates. So this one you go down 1 and you go over 2. Okay. And you just keep repeating the pattern a few more times to give you a more accurate graph. So go down 1, go over 2, right? See over here? Go down 1 over 2, right? Go down 1 over 2. Right? Negative is go down. Okay? So you just go down 1, right? Go down 1 over 2. That's what a slope is. Okay? So after you get a few points using the same pattern, and that's your graph. See that? So again, negative 1 over 2 means you go down 1 over 2. Now what happens if you put a negative on the bottom? What happens if you do this? Well, that means you have to go up 1 and go this way, right? Okay? So positive 2 means you go to the right. Negative 2 means you go to the left. In this case, you have to go up 1. So in this case, you have to go up 1 and you have to go over 2. Right? So you end up right over here. So what you have is, if you put a negative on top, you end up going downhill, going to the right. You're going this way. If you put a negative on the bottom, you end up going that way. But it's going to end up on the same line. So that's why it does not matter if you put negative on top or negative on the bottom. But you have to keep track of your direction, the direction that you're going. So that's what a slope and intercept is used for. You can sketch the graph very quick. Okay. So this is a slope-intercept method. And let's go to example 7. Example 7, we already did this earlier using the slope-intercept. This one actually, you don't want to use a slope-intercept method. It's easier if you use the intercept method. Okay. So example 7. So you got 3x minus y equal to 4. Okay. But they want you to use a slope-intercept method. That means you have to put in that proper form first. So that means you have to solve for y. So minus 3x minus 3x. So you got negative y equal to negative 3x plus 4. Then you have to divide by negative 1. So you got y equal to 3x minus 4. So now when you go in the graph, you have to put in a fraction. So make into 3 over 1. So when you're doing the graphing, negative 4, right? So that's going to be 1, 2, 3, 4, negative 4. So that's your starting point. And that means you have to go up 3 over 1. So you go up 3. So go up 3, go over 1, up 3. So up 3 over 1. Okay? And so your graph would be like this. Okay? So again, intercept is -4, so you go 1, 2, 3, 4, -4. And then the slope is up 3 over 1. So once you get, so this is your starting point. So you go -4, then you go up 3 over 1, up 3 over 1, right? So 3, 1, 3, 1. And that's how you graph.